All right, this is Chapter 4, test review. This is a morning review session from Part 1, the non-calculator portion. So number 1, find the average value of f prime, and f prime is given in this graph here, on the interval from -4 to 4. So if you remember, average value theorem says is equal to 1 over b minus a times the definite integral from a to b of f prime of x dx. And essentially it is displacement divided by the width is equal to the height. So in other words, really we're just taking the area formula for a rectangle, rearranging it to solve for height. Okay. The a value is -4, b value is +4, so we plug that information in. So that'll give us 1 over 4 minus -4, definite integral from -4 to 4 of f prime x dx. So to find this information, we can simply look at the graph and identify the integral values for each of these regions using what we know from geometric shapes. So we have triangle, square, squares, and we can just find all these areas and find the integral value there. Okay. 1/2 base times height. Any region that sits below the x-axis, we have to keep that as a negative value. 1/2 base times height here is 1/2 square, 1 times 1, 1/2 here. The area is -1/2, -1/2. These two regions sits below the x-axis. +1/2 and then 1. Okay. So then when we go through and add these values together, many of these values will cancel out, and the sum will come out to be 2, +2. So the definite integral from -4 to +4 is going to be a +2. So 1/8 times 2 is simply 2/8, which is 1/4. So we have our average value with 1/4. Okay. Number 2, find the average value of f of x is equal to 4 minus x squared from 0 to 2. Okay. So now, rather than given the graph and we have to find the values by finding area, we can use the power rule to find the definite integral for this given function. So like before, we're just plugging in to the formula, average value 1 over b minus a, definite integral from 0 to 2 of 4 minus x squared dx. So just to focus on the definite integral of 4 minus x squared, we can go through power rule. So 4 becomes 4x, x squared becomes x cubed over 3. So we simply plug, to evaluate this definite integral, we plug in the upper bound first. So 2 goes in for all the x's that we see. So 4 times 2 is 8. 2 cubed is 8 over 3 is the denominator. So that is the first part. Minus, now we can plug the lower bound in. So 0 goes in for both the x's, and that will cancel out. We'll make each term 0, so f of a will just drop out to be 0. So we have 8 minus 8/3. This is the definite integral. Times 1/2. We don't want to forget the 1/2, which was from in front here, 1 over b minus a. So 8 minus 8/3 is simply 16/3 times 1/2 will give us 16 over 6, which reduces to be 8/3. Okay. Part B, find the C value guaranteed by the average value theorem. So the way we find the C value is we set our function equal to the average value that we just found. We want to find out when is this curve going to cross this specific y value. Okay. So 4 minus x squared is our function. We set it equal to our average value, and then we just go through algebraic steps to solve for x squared. Okay, subtract 4 from both sides. -x squared equals 8/3 minus 4. Find a common denominator. 8/3 minus 12 thirds will give us negative 4 thirds. Okay. We can divide negative 1 from both sides of the equation. So we get x squared equals positive 4 over 3. Take the square root of both sides. X equals plus or minus square root of 4 over 3. And so this reduces to be plus or minus 2 over root 3. However, our c value has to sit between or on the endpoints. So negative 2 over root 3 is outside of our interval. So we take that out. Our only c value will be positive 2 over root 3. All right, number 3, absolute value, indefinite integral of x minus 2 divided by the fourth root of x squared minus 4x. So we can't rely just on power rule to solve. We have too many terms inside the radical, so we may have to go through use substitution. So first, I'm rewriting this as x squared minus 4x to the 1/4. We simply want our u value to be what's inside the parentheses. So x squared minus 4x is equal to u. Du over dx is equal to 2x minus 4. Solve for dx. Dx is equal to du over 2x minus 4. So now we make our substitution. We can substitute what's inside the parentheses with u, and we have to the 1/4. X minus 2 doesn't get replaced for right now. Times dx gets replaced with du over 2x minus 4. Now we want to look to see what can cancel out. X minus 2 and 2x minus 4 doesn't quite yet cancel out, but what we can do is we can factor out a 2, which leaves us with x minus 2. And then we see that we have some common factors that we can take out. So x minus 2 cancels out. There's a 2 remaining. We don't want to lose this, so we pull the 2 outside the integral, making it 1/2 because this 2 is in the denominator. So 1/2 times the integral of u to the negative 1/4. Now we can go through power rule. So add 1 to the exponent. Negative 1/4 plus 4 is 3/4, divided by our new exponent. Okay. We take the 3/4 and we put the reciprocal up at the top. So 1/2 times 4 thirds, u to the 3/4. The 4 and the 2 cancel out, so we're left with 2 thirds u to the 3/4 plus c. And then finally, don't forget, we want to represent our solution in terms of our original variable, which is x. All right, number 4. Definite integral of the absolute value of x plus 3 from negative 5 to 2. So we know it's best if we can draw this out, that we the triangle, and then we're simply just going to add the areas of triangles together to get equal. So x plus 3, we know the vertex is at negative 3, 0. Okay. All absolute value functions will have the shape of a v right side up or v upside down. In this case, right side up. And we know that our endpoints are at negative 5 and positive 2. So we're just going to extend the graph until we reach those endpoints. Okay. These are two linear equations. One is positive x plus 3. The other is negative x 3. So if we want to find these endpoints, these corners of these upper corners of these triangles, we can simply plug the appropriate x value into the linear equation. So if I plug negative 5 in for x, 2 negatives cancel out, so 5 minus 3 equals 2. Okay. On the other side, I'll plug 5 into my linear equation x plus 3. So 5 plus 3 is, plug this x value 2 into the linear equation x plus 3. So 2 plus 3 gives me 5. So we simply add the two areas of these triangles together. Okay. Each triangle is 1/2 base times height. So 1/2 base is 2 units. Height is 2 units as well. So 1/2 2 times 2 gives us 2. And this side here, 1/2 base, our base is 5. Our height is also 5. So 25 over 2 will be the area of the second triangle. 2 plus 25 over 2 is equal to 14.5, or 29 over 2. Okay. Or we can write this as two definite integrals. The first definite integral is under this graph, negative x minus 3 from negative 5 to negative 3. So that's what we have here. Plus the definite integral from negative 3 to positive 2 of this curve x plus 3. Okay, so once we have this, then we can go through power rule and evaluate these definite integrals using the rules that we know. So negative x minus 3 becomes negative x squared over 2 minus 3x by applying power rule. Evaluate using your upper and lower bound. Plug in upper bound first. So negative 3 goes in for both x's. We get negative 9 halves plus 9. Then plug in negative 5 in for both. We get negative 25 halves plus 15. Combine these terms, and we get positive 2. On the other side, x becomes x squared over 2. 3 becomes 3x. We plug the upper bound first. So 2 goes in for x. We get 4 halves plus 6. Then plug in the lower bound, negative 3. So we get 9 halves minus 9. So combine these like terms, we get 12.5. So 12.5 plus 2, we're going to get the same result as we did from doing it this other method, using adding areas of these triangles. And we're going to get 14.5, or 29 over 2.